Okay. So, welcome back. I had a little bit of technical difficulty. Hopefully we have the other recording saved so that you guys can go back and look at it from before. We're going to pick up where we left off before the technical difficulty, and then we don't have much left. We have the concavity, increasing and decreasing relative max, and then we're going to go into basic integrals just so you guys have like a reference of, make sure you're able to do it before you guys jump in head on in class. Okay, so let's see. We were here. Okay, so previous problem, we were talking about how to find relative min, relative max, and also with our critical points. So we had our equation initially. Hopefully you can see that. If not, it's we took the derivative and we ended up with 5t squared minus 12 over 3 times t squared minus 4 to the power of 2/3. Okay? From there, we found that our critical points are plus or minus 2, and the square of 12 over 15, and again, the positive and negative form, since we're taking the square root. So then from there, we set up our number line and looked at where our graph was increasing and decreasing, because it's kind of hard to draw this graph by hand. And from there, we found that it's increasing on these 4 intervals of negative infinity, -2, -2 to square root of 12 over 5, square root of 12 over 5 to 2, and 2 to infinity. Note that we're using greater than signs, and, less than signs, as opposed to less than or equal to signs, because we can't actually touch those points. And when we're doing our graphing, it's not increasing or decreasing at that point. That's the point where it changes. We can't actually include it in our interval. Okay. So then when we're looking and seeing, okay, where does this graph have a relative maximum, we're going to look and see, okay, so we have positive here, and then it goes negative. So relative max is going to be negative square root of 12 over 5. Right? Because it goes from positive to negative, so we're going to have an upside down. And then if we say where's our relative min, it's going to be at positive square root of 12 over 5, because we have a negative. Okay. Hopefully that all made sense. Now we're just going to go into the basics of integrals. Hopefully that helped you out this week and next week. If you just joined us, make sure you type your ID number into the chat so that we can log who's here. Okay, so yeah. And if you guys have any questions, let us know. And we can start. Full name? Oh, type your full name into the chat so that we have a record of who's here. And so we're going to start into integrals. And we're going to try and make it a little bit interactive, so have your chat up so we can interact. All right. Yeah. So if we have basic integrals, right? Just as a refresher, if you have an integral of say 5x squared dx, right? What you're going to do with this is you're just going to add 1 to the exponent and then divide it by that new exponent. You get your answer. That's going to be 5x cubed over 3. And then since you don't have a definite integral, remember it's going to be plus c afterwards. Otherwise it's wrong. Okay? If you have something else, like 14x squared plus 12xy minus 3y, and I say take the integral with respect to y, right? We have to make sure we watch that, because then this is going to turn into 14 x squared y plus 6xy squared minus 3y squared over 2. And then again, it's not a definite integral, so it's going to be plus cm. Okay. So these should be easy enough for you to do without really thinking about it, because you're going to be doing a lot more of these in the next few weeks. Okay. So if we do something, say we have integral of x over 3x squared plus 1. Right? So how would we solve this? So we have to make it simpler, right? So we're going to use u substitution. So we're going to set u equal to the most complicated part of the problem. So it's going to be u equals 3x squared plus 1, right? Not 1 over 3x squared plus 1. Just set it to the hardest part. So with that, when we take the derivative, it's going to be 6x dx, right? This is going to help us replace the dx if we rewrite this. So that we get dx equals du over 6x. So we can replace the dx and we can replace the x. So when we plug it back in, we have x over u du over 6x. You notice that the x's cancel out. So we've simplified it. So we can pull the 1/6 out and have 1/6 integral of du over u. And hopefully you guys should know that one by heart. So that's going to be natural log of u. So 1/6 natural log of u. And then again, we write it plus c afterwards. If you leave your answer like this, it's not correct because you have to go back into the terms you were using before. So you have to plug in the 3x squared back into u. So your final answer is actually going to be natural log of 3x squared plus 1. And then plus c. Okay, and then make sure you remember the absolute values, unless the term inside will definitely be positive, then you don't actually need the absolute values. Okay. If you guys just joined back, make sure you type your full name into the chat so we have a log of who's here. Okay. So this next question, I'm actually going to ask you guys to participate. So get ready to type some answers into the chat. Okay. So say we have an integral -2 to 1 of 5x squared over 15x cubed minus 5 dx. Okay. So what method of integration are we going to end up using for this? Anybody? Type your answer into chat. And we just went over one that was similar to it. So we know we're going to either do straight integration or we're going to use u substitution. So what do you guys think? Anybody? No? Okay. Guys, it's like 10 a.m. Wake up. Okay, so if you guys don't know, we're going to be using u substitution, right? So which part are we going to set equal to u? We're going to set the bottom. It's actually going to make it simpler. Okay? So we set u equals to 15x cubed minus 5. So du is going to be 45x squared. Right? So when we replace it, it'll be simple. For now, I'm going to write it as an indefinite integral because these limits don't actually apply when we plug u in. So we're going to have to switch it back to the x terms to be able to use those limits. Remember that. So we have a 5x squared over u times the du over 45x squared. So again, our x squareds cancel out, which is what we want. And we have 5 over 45. We can reduce that down to 1/9. And we can pull that out. So we're going to have 1/9 integral of du over u. And again, just like the last example, it's going to be natural log, right? we're going to get natural log of u. And then from there, we're going to change the u back to the 15x cubed minus 5. And then we're going to apply our limits. From negative 2 to 1, right? So from here, it's just algebra to make sure that you are able to solve it. In this case, we have to keep the absolute value up because not necessarily everything inside of this equation will give us a positive number, right? And natural log only deals with positive numbers, okay? So, I'm not going to do all of the algebra. You guys can try that out on your own. But when you do, you'll end up with 1/9 times natural log of 2 over 25. Right? And then with this, you have to make sure that you remember your rule to, when you have the subtraction of a natural log minus a natural log, that it's actually going to end up being division. So make sure you remember those. Any questions on that? Anybody want to throw in a question? If you guys have something from your homework or anything you guys want me to go over.
All of your considerations should be good with that.
Just a couple more examples and then we'll be done. Okay. So, going off of the trig that we were going over before, right? So if I have, right, from like 0 to x, 1 over x squared plus z squared. Plus 9. Right. Can anybody tell me what that function actually is? You guys don't know. This is actually arctangent, right? It usually is z squared plus 1, and then it's just be a simple arctangent. But since there's a 3, it's going to change slightly. So with this, right, because 9 square root of 9 is 3, and z squared square root of z squared is z. So when we actually take the integral of this, it's going to be 1/3 arctangent of z over 3, right? And then we're integrating it from x 0 to x. And so since arctangent of 0 is 0, it'll be simple enough so that we're just going to end up with the answer of 1/3 arctangent of x over 3, right? So I've seen arctangent come up a lot on tests, especially in the first test. Make sure you know that one. Okay. Another one that's similar that you should be able to do, kind of getting better at it at least, is going to be, say you have an integral of tangent of x dx. Okay. So this looks a little hard, right? And you're like, oh, I don't really know what to do. But you know that tangent is essentially the same thing as sine over cosine, right? So because of that, we can treat it just like any other integration and do a u substitution. So we can do u equals cosine x dx, and then therefore du is going to be sine of x. Sine x dx, right? And then when we substitute it in, we're going to have the sine x over u times du over sine x. And then because of that, we have the sine x cancel out. Right? So that's going to leave us again with du over u is going to give us a natural log of u, right? And then plus c. And we're not done yet, right? Because we have a u, we start with an x, so we plug back in our u. So it's going to be natural log of cosine of x plus. Right? And that would be your answer for that one. Okay? So kind of as just like notes for how to study, especially coming up to your first test. Just make sure you remember all of your trig. Make sure you remember how to do your integrations properly. Make sure you remember your area formulas when you're doing area and volume under a curve. Those will come up a lot. And then just watch your algebra, because otherwise, it'll be a mess. You'll do all the work, and then it'll be mess. So always watch your algebra. I know I speak from experience that I make a bunch of mistakes in regards to algebra. But if you guys don't have any specific questions, I think that's it for our first review session. Hopefully that helps, and if you guys can give us any feedback, that would be great. And we can hopefully host another review session before your first test. So one last thing before we end the chat, if you could type your full name into the chat so that we have a log of whoever is here, that'd be great. Okay, so I'll be on standby for like the next minute if you guys have any questions that you want me to answer.
You okay? Yeah, they're all.
Yeah. Awesome. Okay. So if there aren't any questions, hopefully we'll see you guys around in the Learning Center. If you want to come by today, I'm here till 3, so let me know if you guys have any questions. Otherwise, thanks for joining.